All right, this is lesson 7.3, day 1. It's a pretty big lesson. We're going to end up splitting it into 2 days. And in fact, this one, I've not recorded this video yet. Any other time, my guess is this is going to be a long video, so heads up. But definitely pause this at any time if any part of it doesn't make sense. It is something that you have to pay very close attention to details. But if you do that early, you pay attention to details early, it kind of gets easier then. But if you just kind of half listen and you're not really paying attention, suddenly you're going to find yourself lost, believe me. So first thing here is I can identify a system in triangular form. I have a spelling there, in triangular form. So first off, that's something new. What's triangular form? And I can use Gaussian elimination, which is another word, to eliminate to transform a system into triangular form. So a triangular form of a system is an equivalent form from which the solution is easy to read. A lot of fun words there. But they call it triangular form. You look at this guy, it looks like a triangle. Okay, that's why we call it triangular form. And the reason why we say this, why this is so awesome, we'll think of this as row 1, row 2, and row 3. So row 1, row 2, row 3. If I gave this to you on a test or a quiz, this one's easy because it's almost done for you. Because what I would do is, you take this R3, Z is 3, substitute it up here. Okay, so I could substitute R3 into R2. So this row 2 would be y minus 2 times, and then z is 3 equals -7. Add 6 to both sides. So y is now -1. So now I have z is 3, y is -1. I am almost done solving. And then the last thing we'd do would be to substitute row 3 and y equals -1 into row 1. And you're saying, why is he writing everything down? Because when you're doing this today, we want to annotate every step we take. Because this stuff is so easy to make a mistake, you want to be able to go back and look at what was I thinking on that step. What did I intend to do, and did I do it correctly? Because at some point you may get to the end and you have completely wrong answers and you want to go back and double check. Okay, so I'm going to take row 3, which is z3, z equals 3, so I got x minus, and then this also says y equals -1. So I'm putting -1 in for y, 3 in for z. So this would be, see, 2 plus 3 is 5. So I'm going to put -5 on this side. So x equals 2. And so this triangular form is really easy because in a couple steps I'm done. I've got the system solved. Okay. Now, most systems are not in triangular form. It would be nice if they were, but they're not. And you have to transform it to get it into the simplest form. So we're going to do some work to it to try to get it into this form. We like it in this form. We love it in triangular form. The process of transforming a system into triangular form is known as Gaussian elimination. And yes, that is a guy's name. He was a mathematician and came up with this. So he named this whole thing after himself. It would be fun to do. Have some Howard elimination that kids are doing a couple hundred years from now. But here are the operations needed. So there's basically 3 operations we're going to do. One operation we could do is we could interchange any 2 equations anytime we want. So you just flip-flop. If I wanted the first and second equation, I could just flip them, and that's okay. If that helps me get to triangular form, I'm going to do it. You can also multiply or divide one of the equations by any non-zero real number. Now, the reason why it has to be non-zero is because if I took one of these equations and multiplied everything by 0, that I lose that equation. So you don't want to do 0, but anything non-zero you can do. So I can multiply the first equation by -1 if I wanted to. Multiply everything by -1 or by +7 or whatever it takes. And then I can also add a multiple of one equation. Multiply one equation, add it to another equation in the system and replace it. Okay, so that's kind of a fast way of doing this. Okay, so first off, let's name these guys. I got row 1, row 2, row 3. Again, my goal is to get triangular form. I want one equation with just z, another equation with y's and z's, and a third equation with x, y, and z on top. Okay, so my goal is to get rid of stuff. And what I like to do is try to get rid of x's first, and two of them. I want to get two of these equations, I want to get rid of the x's. So probably the easiest thing to do would be use this equation, a multiple of the first equation, add it to the second to get rid of it. So notice if I tripled this, or if it took it times -3, -3x would cancel out 3x. That's what I'm going to do. I'm going to take row 1 times -3, and then I'm going to add to row 2. And that's going to replace row 2. Okay, so row 1 is not going to change. And row 3 is not going to change. I'm just going to copy those down. That's why I said this is going to be a long video. So take the first equation times -3, add to the second. So this would be a -3x plus this would be 0. -2 times -3, that'd be a +6. +6 plus -5 result in 1y. -3z plus z would be a -2z. -3 times 7 is -21, plus 14 would be a -7. Okay? So I multiplied row 1 times -3, I added to row 2, and then that replaced row 2. The result replaced row 2. So I got rid of that x. Now I want to get rid of this x. Well, I could take this times -2, add to that, and get rid of it. So I want to take row 1, the original row 1, or I could say this row 1 too, times -2, add to row 3, and then I'm going to replace row 3 with that. So first two rows are not getting touched. I'm going to leave them alone. If you notice, I always put a line through my z's just so I don't think that it's a 2. So that's kind of a helpful hint for you guys if you want to use that. Saves a lot of mistakes and frustration later. So I'm going to take the first row times -2, add to the third row. So -2 times x is -2, add, that's going to be 0. -2 times -2 would be a +4, plus 2 would be 2. -2z minus z is a -3z. -14 plus 3 is a -11. Okay? So I got rid of the x's in two of them. I'm getting really close to triangular form. I want a triangle though. I want one equation. One of them has to have just z's in them. So I need to get rid of the y. Okay, now it'd probably be really easy to take this y, take it times -2 and add to that, and I'd get rid of that y. So I'm going to take row 2 times -2. I'm going to add to row 3 and then replace row 3 with it. So first row is going to stay the same. Second row is actually going to stay the same. And then the third row here, so I'm going to take the second row times -2, so it would be -2y plus 2y is 0. -2 times -2, that'd be a +4, minus 3 would be a z. And then -7 times -2 is 14. 14 plus -11 is 3. And notice, triangular form, which is what I wanted. So there's my triangular form. That's what it's a really bad triangle, but you get the idea. That's what I wanted. Probably looks a little familiar. It's right there, okay? So if we say go ahead and solve it, well, I've already solved it above. X minus 2y plus 2. You had no idea by looking at it. These two are equivalent systems. They are the same system. It doesn't look like it, but they're the same system. So if I were to, computer froze. Video, there it goes. So if I'm going to continue to solve, z equals 3, plug 3 in up here, and you get y, we set up above, and I'm just looking up here, is -1. And then x was 2. So my solution, I don't know what, so 2, -1, and 3 would be the solution to that system. Okay, so it gets a triangular form, and then up here, triangular form, solve it. So that's the entire work for one problem. So it seems a little ridiculous. Gaussian elimination is not fun, but it is helpful. It is faster than some other methods probably are. Okay, so this guy, and we want to look it over. I'm thinking triangular form. How can I get to triangular form? Remember, I want one equation with x, y, z. I want another equation with just y's and z's. I want a third equation with just z's. And we might be getting a little excited and see x and z. If there's 2, that would be my second row. But that's x and z, and I want y and z in the second row, and then just z's in the third row. So we don't want to do that. But I do want to start getting rid of x's. I want to eliminate x's for 2 of the equations. I see if I add these two together right here, those x's would cancel out. So I'm going to take row 1 plus row 3. I'm going to replace row 3. Whoops. So it's going to be replaced, or going to go into row 3. So row 1 is going to stay the same. Row 2 is going to stay the same. And then row 3, if I add these together, again, no multiplication, just add them. So it'd be 0x minus 2y plus 3z equals negative 1. It's a good first start here. And that has y's and z's in them. That'd be a really good second row. Because x, y, z, y, z, z is my triangular form. So I'm going to take row 2 and row 3. I'm going to interchange them. So I just put in a two-sided arrow here. X minus y plus z equals 0. Negative 2y plus 3z equals negative 1. And then 2x minus 3z equals negative 1. So now, again, I want this to have just z's in it. So I'm going to get rid of that 2x. Well, here's an x. If I took that times negative 2 and added it to get rid of that x. So I'm going to take row 1 times negative 2, add it to row 3. You'll notice when I do this, I get rid of the x's, but I'm going to be adding y's. That's okay. That's fine. I just want to get rid of x's right now. Get rid of x's. So double this one. So it'd be negative 2x plus 2x is gone. Actually, let me write this down real quick. Let me do this part. So now I got double this. Oops, double this. Add to that, that's 0. Double negative y, actually be a negative 2 times negative y would be a positive 2y. There's no y's down here, so it's going to be a positive 2y. And then negative 2z plus negative 3z would be negative 5z. And then negative 2 times 0 is 0, plus negative 1 is negative 1. So I got rid of the x's, but then I added y's into this, but that's okay, because now one of these I want to get rid of y's to have an equation of just z's on bottom. So I'm going to take row 2 plus row 3 and then put that into row 3. So row 1 is still x minus y plus z equals 0. Row 2 is still negative 2y plus 3z equals negative 1. But then this one, if I add these two together, it's going to be a 0y, negative 2z, and negative 2. And then to get triangular form, I'm just going to finish this off and say that z would equal 1. So let me just do this. Z would equal 1. I don't want to rewrite the whole system for that. So now I've got my triangular form. Perfect. Z equals 1. So now my final answer is going to be something, comma, 1. Plug that in up above here. So negative 2y plus 3 equals negative 1. 2y equals negative 4, so y equals 2. And then plug in 2 and 1 in the first equation, so x minus 2 plus 1 equals 0. Now this is a negative 1, so I'm going to add 1 to both sides. So x equals 1. So once I got the triangular form, everything's easy. Everything's easy to solve. Okay? Well, this video is not going to be as long as I thought it would be. That's all right. Now, augmented matrix, I'm just kind of introducing this. We're not going to do anything with it yet. Just got to be able to identify it and work with it. Matrices can be used to record the coefficients of a system. So if you look at this system here, here's some coefficients. 1, negative 1, 1, 0. Those are the coefficients. Well, I may want to just record those into a matrix. Okay, so again, a matrix is just an order here, order of organizing data. So 1, negative 2, 1, 1, negative 2, 1, 7, 7. Just copy it over, and that's called an augmented matrix. Okay, so all you have to do is identify what an augmented matrix is. Tomorrow we'll do some work with it, but identify it for right now. So complete the augmented matrix for the following system. Oh, it's the same problem. I copied the same one over, didn't I? Well, shoot. Oh well. Cover that up, act like you didn't see it. Okay, cover that up. So 1, negative 2, 1, 7. 3, negative 5, 1, 14. Yeah, I'm leaving a gap here, but you don't really want to leave a gap. That's just habits of mine. Whoops. 2, negative 1, 3. I don't want an x in there. We don't want that x to be present. Okay, so let me get rid of that. So anyway, there's the augmented matrix. So you got to be able to do that for your homework too. Just identify converting system into its augmented matrix.